we're going to review for your conceptual unit 8 review. It says, are the directed line segments A, B, and C, D equivalent? If they're equivalent, then they'll have the same components. So the vector form of AB is going to be, you would take A and B and do the head minus tail rule. So that's going to be -5 minus a -4 and 7 minus 3. Sorry, those should be pointy. That's going to give me -1, 4. The vector of CD is going to be head minus tail rule. It's going to be 1 minus 2 and 6 minus 2, which again gives me -1, 4. They have the same vector components, so they are equivalent directed line segments. In this review, I put an example where it was all worked out by Math Excel, because a lot of these I do different than the book does. So I know as you went through Math Excel, you probably found that they walked you through it if you went through the steps differently than I did. So I put an example next to each one. I'm not going to work out this one. It's the same as the last one. It just explains what we did. All right, so I put one of those after every single problem today. All right, so the next one, they want the component form and magnitude of the directed line segment PQ. So first of all, we have to find the vector components of PQ, which is going to be -2 minus 5 and 7 minus a -3. That gives me -7, 10. To find the magnitude of vector PQ, you take the square root of a squared plus b squared, and that gives me the square root of 149. So there's my vector components, and there's my magnitude. Again, the next problem is just an example, just like the one we did. Okay, the next one, number 3, it says evaluate A minus B for A equal 4, 4 and B equal 2, 3. So A minus B would be 4, 4 minus 2, 3. And so that becomes 4 minus 2 and 4 minus 3, which gives me 2, 1. Okay. Again, the next one is an example worked out on the computer. Number 4, perform the calculations given that U equals 9, 3 and V equals 10, 7. They want me to find 3 times U plus 4 times V. Well, we multiply first, and this is just like distributing. So this vector becomes 27, 9. And this vector becomes 40, 28. So then if you add those, you get 27 plus 40 and 9 plus 28, which gives me 67, 37. Okay, next one is an example worked out. Number 5, find a unit vector. Find the unit vector that has the same direction as the vector v. To find a unit vector, you take the vector over its magnitude. So my vector is going to be 2, -17. So there's my vector on top. I got to find the magnitude of v, which is going to be the square root of 2 squared plus -17 squared, which is the square root of 293. So that's what goes on the bottom. And then if you break it up into its components, that's 2 over the square root of 293. And -17 over the square root of 293. And then if you write it in, it says type your answer in the form AI plus BJ. So this would be 2 over the square root of 293I minus 17 over the square root of 293J. Okay, next one is just an example. Number 6, find the unit vector in the direction of the given vector. So my first thing to do is figure out the absolute value, or not the absolute value, sorry, the magnitude of v would be the square root of 2 squared plus a -1 squared, which would be the square root of 5. So my unit vector is going to be my vector, 2, -1 over its magnitude. Split that up into its components, and you have 2 over the square root of 5 and -1 over the square root of 5. That would be in component form. that would be component form. To write it as a linear combination, you write it as 2 over the square root of 5i minus 1 over the square root of 5j. Okay, next one is just an example. Number 7, find the component form of the vector v shown in the figure. It says that vector v has an angle of 60 degrees and a length of 2. So we're going to use our component form of the vector that says that I can take, the magnitude of v times cosine theta and the magnitude of v times sine theta. So my vector components are going to be, because again, what we know is, we know that this thing has a magnitude of 2 and it has a direction angle of 60 degrees. They want those AB coordinates. So to get the A coordinate, you do this. Well, it told me it has a magnitude of 2. Cosine, its directional angle is 60 degrees. Magnitude is 2. Sine of 60 degrees. And if I type those in, I get 1 and 1.732. Okay? Excuse me. Alright, so this one is just an example. So number 8, it says find the magnitude and direction angle of the vector below. So now they're giving me, if I draw a quick sketch of this, -5, 12, not drawn to scale obviously. Okay, so now we know the components. We're going to use this again to find the components of a vector. You do the magnitude of the vector times cosine theta, magnitude of the vector times sine theta. If I plug in what I know the components. That's -5, that's 12. I know the magnitude, or I can find the magnitude. The magnitude of u is the square root of -5 squared plus 12 squared is the square root of 169, which is 13. So the magnitude of u is 13. Cosine, I'm trying to find that angle, so I don't know theta, and 13 times sine of that angle that I don't know. So now I can, because I know the components, I can say that -5 has to equal 13 cosine theta and 12 has to equal 13 sine theta. You don't have to solve them both. I can either solve -5 equals 13 cosine theta, or I can solve 12 equals 13 sine theta. Again, you don't need to solve them both. So I'm just going to solve this one. Divide by 13. I get -5/13 equals cosine theta. To kill cosine, I'm going to do arc cosine. And that gives me theta equals 112.62 degrees. Now, you always want to stop and make sure that that makes sense. 112.62 degrees would be in the second quadrant, so that does make sense. Remember, if it's not in the same quadrant, we have to do some extra stuff. Alright, next one's an example. Number 9 says find the magnitude and the direction angle of the vector 12i minus 5j. This vector in component form would be 12, -5. The magnitude of v is going to be the square root of 12 squared plus -5 squared, which is the square root of 169, which is 13. So the magnitude of v is 13. Again, I'm using AB equals the magnitude of v times cosine theta, magnitude of v times sine theta. Plug in what I know. I know that the A is 12 and B is -5, and that has to equal the magnitude, which is 13 times cosine theta and 13 times sine theta. So again, I can set up either one. I'm going to set up 12 equals 13 cosine theta. divide by 13, divide by 13, I get cosine theta equals 12 over 13. Arc cosine, both sides, and I get theta equals 22.62 degrees. Stop and see if it makes sense. My vector, 12 right, 5 down, would be in quadrant 4. 22.62 degrees is in quadrant 1. So, to get it into quadrant 4, we take 360 and subtract 22.62, which gives me a theta of 337.38 degrees. Alright, and what that is it basically this is your 22.62, so there you go. Alright, so that one's just an example. So this one says find the magnitude and direction angle theta of this vector. So what they're saying is u equals 4 times cosine 79 degrees I plus sine 79 degrees j. This is written in linear combination form. If I want to change it back to component form, I'm going to have 4, and then this becomes cosine 79 comma sine 79, which makes it 4 times cosine 79 and 4 times sine 79. Okay, so if you use our formula, which says magnitude of v times cosine theta, magnitude of v, magnitude of v times sine theta, you can see that the magnitude has to be 4 and theta has to be 79 degrees. Okay? Alright, next one's just an example. So now we have this next one. We have an airplane is flying on a bearing of 296 degrees at 530 miles an hour. Find the component form of the velocity of the airplane. So let's draw a quick picture of this. Now remember, when you take a bearing, that means it's from north. So if I do 296 degrees from north, that would be around here somewhere in this quadrant. That would be 296 degrees. So if I finish it off to figure out what this little piece is, 360 take away 296 would leave 64 degrees. But my theta needs to be from standard position. So my theta is going to be this 90 degrees plus this 64 degrees, which is going to give me a theta of 154 degrees. So now that I know theta, not the bearing, I know actually theta, and I know the magnitude of my vector is 530 miles per hour, I can set up my, again, they want me to find the component form of the velocity, so they're looking for those coordinates, which are going to be the magnitude of v, which we know is 530 miles an hour, times cosine of 154, and 530 times sine 154. This gives me 500, or this right here comes out to negative 476.36, and this comes out to be 530 comes out to be 232.34. So the component form of my vector is negative 476, if I round to the nearest whole, comma, 232. Which makes sense. Negative 476, positive 232, it's in the right quadrant. All is good. Okay, the next one is just an example, and we have this next one now. Alright, we have an airplane that's flying on a compass heading or a bearing of 320 at 330 miles an hour. A wind is blowing with the bearing of 300 degrees at 40 miles an hour. So we've got two things going on. We've got a plane and we've got a wind. In the homework, I drew them on the same graph, which I think kind of was hard to read in the end. So for the review, I kind of approached it a little bit differently, and I drew two separate graphs. Your plane is coming around at a bearing of 320 degrees. So that would be like this. So if that's 320, then what's left over there is 40 degrees. That would make 360, yes? So my theta for my plane is going to be this 90 plus this 40, which is going to give me theta equals 130 degrees. Okay, for the wind, the wind has a bearing of 300 degrees from north, which means there would be 60 left here. So my theta for my wind is going to be 90 plus 60, which is 150 degrees. So now, if I figure out my plane's components, my plane will have components AB at magnitude 330 times cosine 130 and 330 times sine 130. That gives me negative 212.12, comma 252.79. So the vector components of the plane are negative 212 and 253 if I round. Okay, so now for my wind, for my wind, we're going to have AB equals 40 cosine 150, 40 sine 150. That comes out to be negative 34.64, comma 20. So now to find the actual speed, which is what they want, they're going to want the actual ground speed and the direction angle. Excuse me. So to get the actual speed, and direction, we are going to basically add those two components. So that vector will be the plane vector plus the wind vector. So that vector is going to be negative 212.12 plus the negative 34.64 and 252.79 plus 20, which gives me components of negative 246.8 if I round to the nearest tenth, comma 272.8. And that's your components of the actual speed and direction. So your velocity vector is what you're finding here. This is my velocity vector v, which will be at negative 246.8 to 72.8. So what we do then is we say the magnitude of that vector is going to be the square root of negative 246.8 squared plus 272.8 squared, which gives me approximately 368 miles per hour if I round. Okay, so there's the ground speed. Now I have to find the direction angle. To find my direction angle, is going to be, we can say that these components, negative 246.8 and 272.8, will equal the magnitude 368 times cosine theta, and Dang it. 368 times sine theta. Ugh. Alright, so then what we do is we say, I can solve either one of them. I'm going to solve this one. So I'm going to say negative 24.68, negative 246.8 equals 368 cosine theta. Dang it. I don't know why it's doing that. I apologize. So divide by 368, and you get cosine theta equals, negative 246.8 over 368. Arc cosine. Hitting what I saw, sorry. Dang it. So I get theta equals 132.1 degrees. But this is going to be, this is our theta. This is not from north. Oh! I think it's because I get too close to the bottom. Oh my god. It's not from north. So I'm going to have to fix that. So, dang it. So I'm going to sketch me a quick picture of 132.1, which would be from north. 132.1 would be somewhere over here, which means, let's just call it 132, okay? Let's just call it 132 degrees. So from there to there is 132. I need to measure from north to get the bearing. So if I measure from north, from here to here would be 90. From here to here would be 90. From here to here would be 90. And from here to here would be 48. So that gives me a bearing of 318 degrees. Okay, from north. Alright, so here's just an example. And again, if you look at the way they went through it, it's a little bit different than I did. Alright, so the number 13, it says a basketball is shot at a 45-degree angle with the horizontal. So that's 45 degrees. With direction and initial speed of 38 feet per second. So the magnitude of that is 38. So they want the vector components. Well, again, your AB is going to equal your magnitude of, whatever I called it F, I guess, times cosine 45, and your force, your magnitude, times sine 45. Well, my magnitude was 38, so we have 38 times cosine 45, and we have 38 times sine 45. Now, you could do a calculator and go decimal, but you can see that they want their answers in simplest radical form. This is in the unit circle, so if you go to 45 degrees and cosine it, you get square root of 2 over 2. Same if you sine 45, square root of 2 over 2. So that becomes 38 square roots of 2 over 2, and 38 square roots of 2 over 2. Which, if you reduce the 38 into 2, you get 19 square roots of 2, 19 square roots of 2. There are my vector components for that basketball shot. Alright, there's an example. Number 14. It says for u equal 5, negative 5, and v equal negative 1, 5, find u times v. When you take u times v, you're taking 5, negative 5, times negative 1, 5. So multiply vectors. You do the first times the first and the second times the plus the second times the second. So I have 5 times negative 1 plus negative 5 times 5. That gives me negative 5 plus a negative 25 gives me negative 30. Next problem is just an example. Number 15. Find the dot product of u and v. If you write u in component form, that's 4, negative 4. And if you write v in component form, that's negative 2, 3. So if we multiply those together, we get 4 times negative 2 plus negative 4 times 3, which gives me negative 8 plus negative 12, which gives me negative 20. Okay? Next one's an example. Number 16. It says, find the dot product to find the magnitude of u. Guys, it's so silly to do it two different ways. We know the magnitude of u is the square root of 12 squared plus negative 5 squared. All they're trying to tell you is that another way to find the dot product or the magnitude of u is basically to take u times itself, which would be 12 negative 5 times 12 negative 5, which would be 12 times 12 plus negative 5 times negative 5, yeah, except for it would be the square root of that. Anyway, so the magnitude of u would be the same as, yeah, taking 12 negative 5 times 12 negative 5, which gives me, but it's the square root of that, it would give me the square root of 12 squared plus a negative 5 squared, which gives me the square root of 169, which gives me 13. And you've gotten the same thing doing it over here. That would have been 144 plus, would have been 169, which is the 13. I don't really see the point. I mean, just remember that. Nobody's going to know how you did it. Alright, so the next one's an example. 17. Find the angle between u and v to the nearest tenth of a degree. That formula is cosine theta equals u times v over the magnitude of u times the magnitude of v. So, we say cosine theta equals negative 4, negative 5 times negative 5, 2 over, I got to figure out the magnitude of u, which is going to be the square root of negative 4 squared plus negative 5 squared, which is the square root of 41. I got to find the magnitude of v, which is the square root of negative 5 squared plus 2 squared, which is the square root of 29. So I have, on bottom, the square root of 41 times the square root of 29. On top, I'm going to have cosine theta equals negative 4 times negative 5 plus negative 5 times 2 over the square root of 1189. I just typed 41 times 29. On top, that's going to give me 20 plus a negative 10. So now I have cosine theta equals 10 over the square root of 1189. To kill cosine, I'm going to arc cosine, and I get theta equals 73.1 degrees. There you go. Alright, next one's an example. They want the angle between these two vectors. Same thing, it's just that they gave us them in linear combination form. So if I just write them in component form, that's going to be 1, 1, and b is going to be 2, negative 4. So to find the angle between them, we take u times v over the magnitude of u times the magnitude of v. So I have cosine theta equals 1, 1 times 2, negative 4 over, I gotta get my magnitudes. My magnitude of a is going to be the square root of 1 squared plus 1 squared, which is the square root of 2. And the magnitude of b is the square root of 2 squared plus negative 4 squared, which is the square root of 20. So on the bottom I have the square root of 2 and the square root of 20. Simplifying, cosine theta equals 1 times 2 plus 1 times negative 4 over the square root of 40. That is going to give me 2 plus a negative 4, cosine theta equals negative 2 over the square root of 40. Kill cosine with arc cosine, and I get theta equals 108.4 degrees. Okay, example number 19. Use an algebraic method to find the angle between the vectors. Use a calculator to approximate exact answers when appropriate. Alright, so we have u is 5,2 and v is negative 4,3. And cosine theta equals u times v over the magnitude of u times the magnitude of v. So I set it up and I have cosine theta equals u times v over, I've got to get the magnitude of u, it's going to be the square root of 5 squared plus 2 squared is going to be the square root of 29. And the magnitude of v is the square root of negative 4 squared plus 3 squared, which is the square root of 25, which is just 5. But you know what, you're going to, I really ran into typing when I simplified that, so let me show you. Be careful when you get a whole number and not two radicals. So that's going to be the square root of 29 times 5. So simplifying, I would get cosine theta equals 5 times negative 4 plus 2 times 3 over 5 square roots of 29. On top, that's going to be negative 20 plus 6 is going to be negative 14 over 5 square roots of 29. To kill cosine, I'm going to use arc cos. And I get theta equals, now be careful, when you type this in, it opens parentheses. You're going to type negative 14 divided by parentheses 5 square roots of 29, double close your parentheses. If you don't put parentheses around that 5 square root of 29, it divides the 14 by 5 and then multiplies that by the square root of 29. And trust me, that's how I typed it. You don't get the right answer. But if you type it right, your theta will equal 121.3 degrees. Okay, next one is an example. Number 20. It says, determine whether the vectors are orthogonal. Two vectors are orthogonal if and only if their dot product equals 0. So if I take negative 1, 4, and I multiply it by 8, negative 2, that would be negative 1 times 8 plus 4 times negative 2. That's negative 8 plus negative 8 plus a negative 8 is negative 16. That does not equal 0, so no, these are not orthogonal. Now, had it asked for are they orthogonal, parallel, or neither, once you get no for orthogonal, you'd actually have to find theta to decide whether they were parallel or neither. Alright, so next one's an example, 21. It says, find the vector projection of u onto v, then write u as the sum of two orthogonal vectors, one of which is the projection of v onto u. So, if I start off by saying, to project v onto u, we have this formula. To project u onto v is going to be u times v over the magnitude of v squared times the vector v. So what we're trying to figure out, they want us to rewrite u as a sum of two orthogonal vectors. So I'm trying to say that u equals u1 plus u2. And these two have to be perpendicular vectors. Well, to find this one, you calculate the projection of u onto v. To find this one, you would subtract u1, and u2 would equal u minus u1. So this is how you find u1, this is how you find u2, and then you can rewrite it as u equals this plus this. So that's my plan. So I've got to figure out what the projection of u onto v is. So I say, here we go, yep. So I say the projection of u onto v is 7, negative 8 times 3, 7 over, I need the magnitude of v, right? Because I need the magnitude of v. My v is going to be the square root of 3 squared plus 7 squared, which is going to be the square root of 58. So I put that over the square root of 58 squared, and then all of that is going to get multiplied by vector b, which is 3, 7. So if I simplify inside parentheses first, I'm going to get 7 times 3 plus negative 8 times 7 over 58 times 3, 7. This is going to give me, this is 21 minus 56, so that gives me negative 35 over 58 times 3, 7. That gives me, if you take negative 35 times 3, you get negative 105 over 58, and negative 35 times 7 is negative 245 over 58. So there is the projection of u onto v, and that also is u1. Okay, so now to figure out u2, I take u, which was 3, 7, and I subtract u1, which is a negative 105 over 58, and a negative 245 over 58. And if I simplify that, I get u2 equals I don't want b, I want u. I'm trying to rewrite u. Stupid. Sorry. U is 7, 8. 7, negative 8. My bad. So u2 is going to be 7 minus a negative 105 over 58, and negative 8 minus a negative 245 over 58. That is going to give me 511 over 58, and negative 219 over 58. So, there, again, the projection of v onto u is this. And then what they're asking you to find is basically u2 here, which is the 511 over 58 and negative 219 over 58. I can say that 7, negative 8 is equal to my projection, negative 105 over 58, negative 245 over 58, plus u2, which is 511 over 58 and negative 219 over 58. Okay? Alrighty. Next one's an example. 22. Find the vector projection of u onto v, then write u as the sum of two orthogonal vectors, one of which is the projection of v onto u. So same thing. To find the projection of u onto v, it's going to be u times v over the magnitude of v squared times v. So I will have, let's figure out our magnitude of v is going to be the square root of negative 4 squared plus negative 4 squared, which will be the square root of 32. And then also remember that u2 is equal to u minus u1. So, to find the projection of v onto u, I'm going to say negative 2, negative 5 times negative 4, negative 4 over the square root of 32 squared times negative 4, negative 4. This comes out to negative 2 times negative 4 plus negative 5 times negative 4 over 32 times negative 4, negative 4. On top, that gives me an 8 plus a 20, so that gives me 28 over 32. negative 4, negative 4. If I reduce, that's 7/8, negative 4, negative 4. Distribute, you're going to have negative 28 over 8, negative 28 over 8. And that reduces down to negative 7/2, negative 7/2. So there's U1. Okay? So to get U2, I take U, which is negative 2, negative 5, and I subtract U1, which is negative 7/2, negative 7/2. That gives me U2 equals negative 2 minus a negative 7/2, and negative 5 minus a negative 7/2, which gives me U2 equals 3/2, comma, negative 3/2. So there's your U1, and there's your U2. Yeah? Alright, next one is an example, number 23. It says, find the interior angles of the triangle with the given vertices. So the first thing I did was make a sketch of this triangle. And I'm not going to do it to scale this time. You got A up here, you got C here, you got B way over here. So you've got B at 4, negative 9. You've got A at negative 8, 2. And you've got C at negative 9, negative 2. So what we have to do, people, is we have to figure out all these angles. They want to know what are the measures of each of these angles. Well, if I can find the vectors, then I can find the angles between them. So if I start off finding vector AB, which is this one, we do, vector AB, we're going to do head minus tail, so 4 minus a negative 8, comma, negative 9 minus 2 gives me a vector of 12, negative 11. The magnitude of vector AB is going to be the square root of 12 squared plus negative 11 squared gives me the square root of 265. Vector CB, which will be this one, alright, is going to be negative 8 minus a negative 9, 2 minus a negative 2, gives me, oh crap, I'm reading the wrong one, sorry, I'm reading CA. CB is 4 minus a negative 9, and negative 9 minus a negative 2, which gives me 13, negative 7, and the magnitude of vector CB is going to be the square root of 13 squared plus negative 7 squared, which gives me the square root of 218. Vector, got one left, vector CA, this one, alright, is going to be negative 8 minus a negative 9, and 2 minus a negative 2, which gives me 1, 4. So the magnitude of vector CA is going to be the square root of 1 squared plus 4 squared, which is the square root of 17. So now that I have all of that mess, alright, I gotta find the three angles. It doesn't matter where you start. I'm going to find A first. So cosine A. If I'm finding cosine A, or if I'm trying to find what A is, that's the vector between AB and AC. These two. So I would say that it is 12, negative 11 times 1, 4 over the magnitude of AB, which is 265, and the magnitude of 1, 4, which is the square root of 17. That gives me cosine A equals 12 times 1 plus negative 11 times 4 over the square root of 4505. On top, I'm going to have 12 minus 44, which gives me cosine A equals negative 32 over the square root of 4505. We have to kill cosine. Alright. Kill cosine. That's what it is. I get too close to the bottom and it flips it. So I get angle A equals, there you go again, 118.5 degrees. Okay? So if I've got 118, get the right answers. I just now noticed that I didn't get the right answers. Oh, that's good. How do you? I got the 14, but why did I screw up the other ones? Huh. Well, I'm going to leave this for you guys to do extra credit and figure out where I screwed up. Because it would make this video really long if I started all over at this point. So you guys figure out where I screwed up, or somebody watching the video tell me where I screwed up and I'll fix it. Hold on just a second. Okay, I figured it out. Here's where I screwed up. Do you see how I did vector AB, which would be in this direction, and vector CB would be in this direction? Then I did CA, which would be in this direction. And see how we're coming down from A, and this is coming down from C, so we need to go in this direction for AC. So what I have to do is change this. Instead of being CA, it's going to be AC, which, yeah, you're going to go, well, it's not going to matter on the magnitude, you're right, but it'll matter on this, which matters on this. So let me back up and erase this. Alright, so if I erase this mess and start over, alright, so we've got vector, oh sorry, I made a quick sketch, not to scale obviously. You got negative 8, 2, you got negative 9, negative 2, and you've got 4, negative 9. That's A, that's B, that's C, there's my triangle. So again, I wasn't paying attention to my direction that I was going, which obviously caused problems. So, let's see, we have vector AB, which will be 4 minus a negative 8, negative 9 minus 2, 12, negative 11. The magnitude of vector AB is going to be the square root of 12 squared plus negative 11 squared, which is the square root of 265. That's AB going this way. So then I'm going to do vector CB, which is going this way. So that would be 4 minus a negative 9. Negative 9 minus a negative 2 gives me 13, negative 7. The magnitude of vector CB is going to be the square root of 13 squared plus negative 7 squared, which is the square root of 218. And now this is where I screwed up. instead of doing vector CA, I need to do vector AC because it needs to be going in this direction. So to do vector AC, I'm going to do -9 minus a -8, -2 minus 2, which gives me -1, -4, which won't change the magnitude because when you square a negative, you get a positive anyway, but so you're still going to get a square root of -1 squared plus -4 squared. But like I said, when you square the negatives, you're still going to end up with a square root of 17. So now we can proceed correctly this time. So if I want to find A, that's between AB, this guy, and AC, this guy. So I take that vector, 12, -11, times this vector, -1, -4, over the magnitude, square root of 265, and the magnitude of that was 17. So that gives me cosine A, which color's here? Cosine A is going to be 12 times -1 plus -11 times -4 over the square root of 4505. That's going to be cosine A equals positive 32 over the square root of 4505. And now, when I arc cosine, there we go again, arc cosine, I get angle A equals 61.5 degrees, which would be 62. There's your 62 degrees. Okay, so now, if I do B, I can say cosine B, and that is between CB and AB. So now I'm just CB and AB, so now I'm looking at these two. So I have 12 -11 times 13 -7 over the magnitude of that one, which is 265, and the magnitude of this one, which was 218. So if I simplify, I'm going to get cosine B equals 12 times 13 plus -11 times -7 over the square root of 57770. If you simplify that, you're going to get 156 here plus 77 there. So that's going to give me cosine B equals 233 over the square root of 57770. So now we're going to arc cos, and I get angle B equals 14.2 degrees, which is the 14 degrees. And you could do find the angle between the other two if you want to, but now that I know 2 and 3 angles make 180, I can just do for angle C 180 minus 62 minus 14, and I get angle C equals 104 degrees. There's the middle. Okay? Sorry about the screw up. There's a review one, or an example of one. 24. Determine whether the vectors A and B are parallel, orthogonal, or neither. So I always decide if they're orthogonal first by doing A times B, which would be -3, 2 times -6, -9. That's going to be -3 times -6 plus 2 times -9. That's 18 minus 18, which is 0, so they are orthogonal. Another example, and this one, we've got, I'm going to change this problem because I don't want to do another one where they come out orthogonal. So I'm actually going to do the example one on the next page. So we're going to use A is 1, 6, and B is 12, 2. Okay, so we're not working this one, because I want to show you one where you have to figure out if they're neither or parallel. So if I'm using these vectors, if I try and see if they're orthogonal, 1, 6 times 12, 2, alright, would be 1 times 12 plus 6 times 2 is 12 plus 12 is 24, which means they are not orthogonal. But, so what are they? Are they parallel or are they neither? Well, I don't know. I got to figure out what theta is. So we use our handy dandy angle between two vectors. It's going to be a times b over the magnitude of a times the magnitude of b. So I'm going to have cosine theta equals 1, 6, 12, 2 over the square root of 37 times the square root of 148. That gives me cosine theta equals 1 times 12 plus 6 times 2 over the square root of 5476. On top, that's 12 plus 12, so I get cosine theta equals 24 over the square root of 5476. Arc cosine, and I get theta equals 71.1 degrees. So that means that they're not parallel either, which means they would be neither. Alright, and remember, what does parallel look like? Parallel means you get theta equals either 0 degrees, or if you get theta equals 180 degrees, then you know that your vectors are parallel to each other. Alright, so next we have an example, and then 26. Ojemba is sitting on a sled on a side of a hill inclined at 60 degrees. So we have this incline, it's more like 30 degrees, Sandra, of 60 degrees. You have this sled sitting here, right? And you have Ojemba holding it and keeping it from sliding down. It says the combined weight of Ojemba and the sled is 190 pounds. So you have a force acting down on this with vector coordinates of 0, negative 190, because it's pushing you down 190. Okay? So what we want to do, this will be what I call my force vector, and this will be my vector. And what we want to do is project, let's try not to cheat, F onto V. And that will be this distance right here to here. Okay, so that's what we're trying to find. In order to find that, I need a couple of things. I need the force of F, which is negative 190. Obviously, the vector components will be 0, negative 190. Then for this vector, remember, we're going to make it a unit vector. So we're going to say the magnitude of V is 1 because it's a unit vector. And I can say then that V equals 1 times cosine 60 and 1 times sine 60. And this one, they're going to want you to leave everything in radical form, I guess until the very end, because you don't want to get off on rounding. So this would be cosine of 60 is 1/2, sine of 60 is the square root of 3 over 2. So there's the component form of V. Yeah? Alright, so here we go. To project F onto V, I'm going to take F times V over the magnitude of V squared times V. So that is going to be 0, negative 190. My V is 1/2 and the square root of 3 over 2. All over, my magnitude is 1 squared times 1/2 square root of 3 over 2. So if I clean this up, I get 0 times 1/2 plus negative 190 times the square root of 3 over 2 all over 1 times 1/2 square root of 3 over 2. So that gives me 0 minus, if this would be this would be 190 square roots of 3 over 2, but 2 goes into 190 95 times square roots of 3 times 1/2 square root of 3 over 2, which gives me negative 95 square roots of 3 times 1/2 and square root of 3 over 2. Distribute that, and my components are negative 95 square roots of 3 over 2, and this would be negative 95 square roots of 9, which is negative 285 over 2. Okay, so there would be my projection of F onto V. Now, to figure out the magnitude of the force, that's the vector, all right, of the force. To find its magnitude, I've got to find the magnitude of the projection of F onto V, which will be the square root of negative 95 square roots of 3 over 2 squared plus negative 285 over 2 squared. So if I do that, and I went decimal on these because my answer was in a decimal, so I was too chicken to try and type all that in with the radicals and the negatives and the fractions, so I just did one at a time. That was 6768.75, and this one was 20306.25, which gives me a square root of 27075, which gives me square root 164.54 pounds. Yeah? Alright, next one's an example, and last but not least, it says, find the work done by a force of 13 pounds acting in the direction 3, -2 in moving an object 7 feet from 0, 0 to 7, 0. So if I draw a quick sketch of that, you have a vector in the direction of 3, -2. It has a force of 13 pounds. You're moving the object from 0, 0 to 7, 0. Okay, so this one obviously has a magnitude of 7. I mean, you can do the math if you want to, because if you, I don't know what you want to call it, but AB, right, would be from 7, take away 0, because this would be 0, 0, right? So the vector components would be 7 minus 0 and 0 minus 0, which would be 7, 0. And the magnitude of AB would be the square root of 7 squared minus 0 squared, which is the square root of 49, which is just 7. Okay? So now if I find the angle between those two vectors, and why am I doing that? Because remember, work is equal to the magnitude of the force times the magnitude of that moving object times cosine theta. So I've got to find theta. So I say cosine theta equals 3, -2 times 7, 0 over the magnitude of this, which will be the square root of 3 squared plus -2 squared, and the magnitude of this will be the square root of 7 squared plus 0 squared. So that gives me cosine theta equals 3 times 7 plus -2 times 0 over the square root of 13 times the square root of 49, which gives me cosine theta equals, this would be 21 plus 0, so that's 21 over the square root of 637. I didn't simplify that this time. And then when you arc cosine, you get theta equals 33.7 degrees. So the work being done is the magnitude of f, which we said was 13, times the magnitude of what you moved, which we said was 7, times cosine theta, which we said is 33.7. So if you type that in, you get 75.70782511, which mine would round to 75.71, and the answer is 0.72, and I'm sure I'm off because I rounded that theta off. So be careful, don't round it off too soon. Give yourself a couple extra decimal points and your rounding should come out. All right, we are done. So happy studying for your test, and